Alright, test 18, study guide for Algebra 2. The temperature of a quantity of ideal gas was held constant at 135 degrees Kelvin. So if they tell us something's held constant, that just means in our original formula, which is P sub 1, V sub 1 over T sub 1 equals P sub 2, V sub 2 over T sub 2. If something's held constant, it simply means that that value is not relevant to the problem. So temperature's held constant, we can just simply throw the temperatures out. So now we've got P1 V1 equals P2 V2. And it says pressure of 1600 is increased to 2000. So our P sub 1 is 1600 newtons per square meter. That's P sub 1. It's increased to 2000 newtons per square meter. That would be P sub 2. And what's the final volume? So we're questioning what's the final volume with the volumes initially 500 milliliters. Okay, the fact that volume's in milliliters initially means our answer is going to be in milliliters also. So it's just a matter of substituting the numbers in properly. So 1600 is P sub 1 being multiplied by the initial volume 500 V sub 1, and that equals the final pressure 2000 times the final volume that we don't know. So to get V sub 2, I simply have to divide all that stuff by 2000. I should have read as a subscript, not as a power. V sub 2 equals, and then it's just a matter of typing in that expression. So 1600 times 500 divided by 2000. And that comes out to 400. And again, we have milliliters as the unit of volume. Number 2, the original mixture weighed 450 pounds and was 70% slaked lime. We're going to be adding a 20% slaked lime mixture to reduce the concentration to 35%. So here's a situation where we start off with a given amount of mixture. So our initial setup is we have 450 pounds of 70% slaked lime. We're going to add a weaker concentration of slaked lime mixture to this. That's going to reduce the concentration of slaked lime. We don't know how much we're going to add to it though. So again, we're starting off with this specific amount. We're adding some unknown amount of weak material, and our goal is to end up with a 35% mixture, and I don't really care how much I end up with as long as it's the right percentage. Everything is slaked lime. Lime concentration 35%, 20% slaked lime, 70% slaked lime. The final amount of mixture, we have 450 pounds. We're adding some unknown number of pounds to it. We're going to end up with 450 plus X pounds of mixture. So that'd be our setup. And then it's just a matter of multiplying. 70 times 450, 31,500 plus 20X. And then 35 times 450 plus X, so that's times this. That was easy to do in my head, so let me just use a calculator for that. 35 times 450 comes out to 15,750 plus 35X. So at this point I want to get X by itself, so I'm going to move the 20X over here, and I'll move the 15,750 over here. $15,750 equals 15x. Divide both sides by 15, we get x equals 1050. And it says how much of 20% should be added. X represents the 20%, so the correct answer is 1,050 pounds of 20% slaked lime. And that's all they're asking us for. They don't want to know the final amount of mixture, 1,500 if they did ask, but all they're asking for is how much 20% needs to be added. That's the correct answer. Number 3, evaluate. And this is just a simple matter of typing in our calculator. I'm going to shrink this up a little bit so I can see the calculator on the screen. There we go. So I've got, and the main thing here is count the zeros. Make sure you count them also. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So I've got 0.000000000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 152, and then the times 10 to the negative third power is just second comma, which is EE, and it shows up as E on your screen, negative 3, and then we divide that by 501,020 times 10 to the ninth, which again is second comma, brings up the E, and then you put in the power of 10. Okay, that's all that has to be typed in, hit enter, and it gives you the answer. So 3.03 times 10 to the negative 28th power. And please write it in good scientific notation structure. Don't write it like some number, E negative 28. I've seen people forget all about the E over there and just write 3.03, but the times 10 to the 28th, the negative 28th is right there. So make sure that know how to enter a scientific notation in your calculator, know how to translate a scientific notation answer back to good form on your test. Number 4, evaluate the 5.12 root of 247. And again, it's just a matter of using our calculator properly. The root gets typed in first, then we hit the math button, and I'm looking for the xth root, which is 5. So the little x, when you use that button, the 5.12 is being called x, and then you type in 247, the radicand. That's if I'm in classic mode. The answer is 2.933. If you're in math print mode, so if I'm going here of mode and I'm in math print, and notice right here it's CL Classic, now it's MP Math Print. If you're in math print mode, you go straight to the math button, choose Math 5, and it creates this structure that we're looking at, 5.12, you put the root where it belongs, press to the right, and then you type in 247, press to the right. So what shows up on your screen is what the problem looks like, hit enter, and you get the same answer. I prefer classic mode myself because I'm used to it, but you're welcome to use whatever mode you want. And number 5 asks us to find the exact values of x and y, and we can see this is a right, it's not marked a right angle, but we can assume that to be right angle for the sake of this test. It's going to be. That's the 60 degree, which makes this 30 degrees up here. 30, 60, 90 right triangle. I want to draw these triangle that we memorized in the same fashion. So right angle bottom right hand corner, 60 degree angle bottom left hand corner, 30 degree angle up top. And the numbers I need to remember are 1, 2, and square root of 3. And if we go based on size, 1's the smallest, goes opposite the smallest angle. 2 is the biggest, goes opposite the biggest angle. Square root of 3 is about 1.7 something. It's between 1 and 2, so it goes opposite the medium-sized angle. Oh, and I wrote 1.73 thinking that, but we actually write the square root of 3. So if we write them in the same fashion, so bottom number matches bottom number, slant number matches slant number, vertical number matches vertical number, I can just do a simple proportion here. The two sides that we know both numbers are 2 and 4, so if I put 2 on top, 4 on bottom, or 4 on top, 2 on bottom, doesn't matter, just pick something. 2 comes from the smaller triangle, so I need all the small triangle measures on top. 1 and the square root of 3 go on top. 4, it comes from the bigger triangle. 1 matches up to x, square root of 3 matches up to y. And then I've got simply this proportion to find out x, so 2x equals 4, divide by 2, we get x equals 2. Obviously that's the exact answer. If I do this proportion, 2y is equal to 4 times the square root of 3. We divide both sides by 2, and the exact answer is 2 times the square root of 3. When it says exact, it's looking for a radical answer, not a decimal approximation. So we're looking for answers along those lines. Make sure that you apply the, use this and apply the similar triangle properties to create a good proportion, and keep it in radical form. Number 6, find the measure of arc MN. And what I'm noticing here is MN is equal to x. So if I find x, I figured out how big arc MN is. But also this arc 75, this arc 3x minus 8, and this arc down here 101 all add up to the entire circle. So altogether those 4 arcs should equal 360. So if I just make that equation, x plus 75 plus 3x minus 8 plus 101 equals 360 degrees because we made a full circle. Combine like terms on the left-hand side, 1x and 3x make a total of 4x. 75 and 101 is 176, minus 8 is 168. So 4x plus 168 equals 360. Move the 168 over and subtract. We get 4x is equal to 192. Divide both sides by 4, we're going to get 48. So x is going to equal 48. So expect on the test it's going to be that same kind of picture. All the arcs add up to 360, solve for x because that's what mn is going to be. Number 7, simplify. You'll notice here that we have a binomial radical denominator, and the fix for a binomial radical to make the denominator a non-radical expression is to multiply by the conjugate. Conjugate is same first object, change the sign of the second object. Multiply both top and bottom by that same thing, like so. So if I do top times top, 3 times 2 square root of 3 is 6 times the square root of 3. 3 times 5 is plus 15. That's just a basic distributive property. On the bottom, all we have to do is first times first and last times last. The outside product and inside product, if we did do the whole FOIL, positive 10 square root of 3, negative 10 square root of 3 cancel. That always happens when you multiply by conjugate. So you can just skip the O and the I part of FOIL and just go straight to FL. Keep in mind when you're multiplying the first, whole number times whole number, square root times square root, we're going to get a whole number product and we're going to get square roots making another whole number. Those two have to multiply together. 5 times 5 is 25 and they're opposite signs, so they're minus 25. And all that's left to do then is to make this the simplest it can be. So multiply 4 and 3 and subtract 25. So we end up with on the bottom 12 minus 25 is negative 13. On top 6 times the square root of 3 plus 15. Number 8, same deal, same type of problem, same fix. So this time 4 times the square root of 3 minus 2. I'm going to multiply by 4 times the square root of 3 plus 2. Do the same on top. Once again, the top is just a basic distributive property. 5 times 4 square root of 3 makes 20 times the square root of 3. 5 times positive 2 is positive 10. On the bottom, first times first. 4 times 4 is 16. Square root of 3 times square root of 3 is 3. Last times last, negative 2 times positive 2 is negative 4. Leave the top as is. 16 times 3 is 48, minus 4 is 44. That's the correct answer. I'm not going to count that wrong. Do notice though that 20, 10, and 44 are all even. Dividing by 2 is legal. Dividing everything by 2, that's a better answer. Again, I won't count this wrong. If it were me, I would go ahead and put this on my test, then reduce. If you reduce it properly, if you have the right answer on your test, I'm going to count it right. I do want to see that you make an effort to reduce fractions. So if you do notice one of these two problems, 7 or 8, do reduce like that. Try to reduce it, but go ahead and have the unreduced form on your test paper. And again, I'll give you full credit for this. If you do that right, you're still getting full credit, obviously. But if you have this correct and do this wrong, I'll still give you full credit for the initial right answer. Okay, number 9. We're supposed to add by getting a common denominator. Before we start worrying about getting a common denominator between these two things here, it's better to have both these denominators factor completely. I can't make 2 minus x any simpler than it is, but x squared minus 4 is x plus 2 and x minus 2. And what you'll notice about this is x minus 2 and 2 minus x are exactly the same thing, except the signs don't match. So that's the kind of the thing you should expect to see here. So what I want to do is I want to make this become x minus 2. I changed every sign in the denominator. I'm required to either change the sign in front or on top. Currently the front sign's a positive, so I'm going to change the top to a negative 1 like so. So at this point I can see that x minus 2 matches x minus 2. That's already common. So what's left to do then is to get this fraction to have an x plus 2 on it. And that requires me to multiply both top and bottom by the same thing, x plus 2, to make that happen. This is a -1 on top, so that -1 distributes through like so. So altogether, on the bottom, I've got my common denominator x plus 2, x minus 2. On top, I've got -1 times x, -1 times 2, minus 4. And the last step of adding fractions, if possible, we should add like terms on top. And you can see here that these are like terms. -x minus 6 over x plus 2 times x minus 2. The bottom can stay factor, the top needs to be simplified completely. If you stop here, I'm going to take off half credit because that should be something you want to learn in Algebra 1 to be able to combine like terms. I expect it to be done completely. Number 10, simplify. Same idea, we're going to add the fractions, but before I can add these two fractions, I need to make the second fraction simpler. So what I'm looking at, if I just take a look at that over here, a is on top, c plus a over c is on bottom. There's my three objects that belong to that main fraction bar here. The numerator's a, the denominator's c plus a over c. The only fraction issue is the a over c inside the fraction. So times its denominator to everything, and you're going to make a simpler fraction. So c times a on top is ac. C times c on the bottom left is c squared. C cancels c there, leaving me with plus a. So ac over c squared plus a is equivalent to what's in this blue box here. So I'm going to keep 3r plus, and then I'm going to change this into that. At this point, that's a fraction. This is a whole number structure. So basically all I need to do is I need to get this denominator on this fraction. So that requires me to put a c squared plus a in the denominator. And to do that, I have to put a c squared plus a in the numerator. And just like the last problem, I've got some distributive property happening over here, so I need to do that. 3r times c squared makes 3c squared r. 3r times a makes plus 3ar. And then plus ac. All that goes over c squared plus a. In this case, there are no like terms in the numerator. The denominator is as simple as it can get, so that's the best answer for that problem. Number 11, we're multiplying imaginary complex numbers. So I'm just going to bring it down here. 1 plus 3i times 2 minus 4i. It's just a binomial times a binomial structure, so it's just going to require us to use FOIL. First times first is going to be 2. Outside times outside, 1 times negative 4i is negative 4i. Inside times inside, positive 3i times positive 2 is positive 6i. And last times last, positive 3i times negative 4i makes negative 12i squared. 2 is real, 4i and 6i are both imaginary to the first power. They're all good. 12i squared we need to fix, and we know that I to the first is equal to I squared is equal to negative 1. So this fact goes here. That makes this whole term become plus 12. So instead of minus 12i squared, I squared is negative 1 times negative 12 makes positive 12. So the end result, real numbers add together first. 2 plus 12 makes positive 14. Imaginary number goes second. Negative 4 plus 6i makes plus 2i. You should expect a binomial times a binomial, complex numbers with no radicals involved, to create a binomial complex number. Number 12, once again, simplifying complex numbers. These guys are being multiplied together. It's being subtracted by this guy. It's being subtracted by this guy. It's being added to this guy, which is being added to 7. So basically we have 5 pieces to this problem. Each piece needs to be fixed individually, if at all. The plus 7 is perfectly fine. Everything else has some fixing to be done. So, first off, I get negatives inside of radicals. Those both create i's. I for this makes a total of I squared. Square root of 3 times square root of 3 makes 3. So the square root of 3 times itself makes the 3. The 2 negatives in the radical create i's, so I squared. That gets that taken care of. I'm going to go ahead and write this minus 4i squared for now. Square root of negative 16, so I got minus. That's that minus. The negative inside makes an I. The square root of 16 is 4. Then I got plus 4i cubed, and I've got plus 7. I'm going to worry about my i's to powers later. I want to deal with the radicals immediately, and negatives inside of radicals even more immediately. Once I get to this point, now I've got i's to powers. Now I'm going to worry about my power rules. So I to the first is I to the second, -1, I to the third, -I to the fourth, +1, and I to the fifth continues on that way. So this purple thing here is just 3 times -1. -1 here times 3 makes -3. This red one, that's -4 times -1 makes +4. For this green one, -4 times I is just -4i. I to the first is perfectly fine. This blue one, 4i to the third. I to the third is -I, so -I times +4 makes -4i. Then of course we have a +7. What's left to do now? Everything's just a real number or just an imaginary number. All the real numbers, -3 plus 4 is 1 plus 7 is 8. -4i minus 4i is -8i. 8 minus 8i is the answer to that. I would expect it to come out similarly on the test, just a simple binomial like that. Real first, imaginary second. 13, I'm supposed to add these vectors and write the final answer in polar form. Shrink this up a little, I'll use a calculator. Okay, the first thing I'm going to notice here is my calculator's in radians, not degrees. So I go to my mode. I'm going to go down here and make sure I'm sitting in degrees because that's what type of form we need in this class. If I start off with this vector, I'm looking for something I, something j. To get the I number, we do the magnitude 15 times the cosine of the angle. To do the j number, we take the magnitude 15 times the sine of the angle. And that comes out to -8.17 I plus 12.58 j. We do the same thing to the second vector. We're adding that to 30 angle 246. So I do 30 cosine of 246. I do 30 sine of 246. And we get negative 12.20 I minus 27.41 j. Just go a couple decimal places on both, that'll be sufficient. Then we simply add the i's and the j's together, either add or subtract based on sign. In this case I'm adding because the signs are both both negative, so 7, 3, 0, carry the 1, 20, negative 20.37 I, and 12.58, negative 27.4 are opposite signs, big minus small, just to be safe, 12.58 minus 27.41 comes out to negative 14.83. That's the correct answer, worth half credit. Okay? It's not polar form, but it is correct. So if you get here and stop there, I'm going to give you half credit. If you even continue on and try to get the polar form, but have the correct rectangular form answer on your paper, I'll give you half credit for that much. Okay, then we've got to go back to polar form. 3 steps in polar form. Step 1, r is going to equal the square root of these two numbers squared added together. Ignore the minus signs. So, the square root of 20.37 squared plus 14.83 squared in parentheses. So it's just square root, the entire expression in parentheses, it equals, and you get 25.20. That's this part. That's already done. Step 2, we're going to find alpha. Alpha is always the inverse tangent of the absolute value. So absolute value means ignore the minuses again. We take the vertical over the horizontal, 14.83 over 20.37. These two steps both require you to use these two numbers as positives. The second step is always the second number over the first number every time. It's always inverse tangent, so make sure you get the second key tan. 14.83 divided by 20.37. And that comes out to 36.06 degrees. This should always be an answer between 0 and 90, that's step 2. As far as step 3 is concerned, now we're worried about the quadrant. If I've got negative I and negative j, that puts me left and down into the third quadrant somewhere. That's my vector that I'm looking at. I'm in the third quadrant. So in the third quadrant, theta is equal to 180 plus alpha. So all step 3 is just establishing what quadrant you're in, and then you're going to take this angle and do something to it. In the first quadrant, alpha equals theta, 180 minus alpha, 180 plus alpha, 360 minus alpha. So depending on where you're at, in this case you get 216.06 degrees. So r is that, theta is that, so that's my answer, 25.20 at an angle of 216.06 degrees. All right, again, if you're doing this problem on your test, make sure that's written on your paper, because if you do something in here wrong and you have this right, you're still going to get half credit for at least getting the rectangular portion of the answer right. You have to get all the way down to polar form to get full credit though. Number 14, we're going to solve this, and the technique we've used so far is completing the square, so I'm going to assume that's what we're going to use here. We also have the quadratic formula at disposal if we wish. I'll do it both ways. You can pick and choose which way you want to do it on the test. So first of all, completing the square, I'm going to move everything to the left. So 5x squared minus 4x plus 3 is equal to 0. Divide by 5, divide by 5, divide by 5, divide by 5. X squared minus 4/5 x equals, gapping this, negative 3/5. All right. So maybe I could have left the negative 3 over there to begin with. Doesn't matter. But we want all the x's on the left, constants on the right. We don't want this to be anything but 1x squared, so we divide by whatever's in front of it, no matter what happens. To complete the square step, I'm going to add the exact same number to both sides, and that exact number is 2/5 squared. We want to take half of this fraction, half the top or double the bottom. Since the top's even, halving the top is easier. So 2/5 squared, so I'm going to add 4/25, which is the same as 2/5 squared. And I need to modify this, negative 3/5, the same as negative 15/25. Multiply top and bottom by 5, get a common denominator. Once I've created that common denominator, the right-hand side is simply going to add together the left-hand side, you get what you get. So here I'm going to get a parentheses squared. I take the square root and the square root, so x and 2/5. I take this sign. On the right-hand side, negative 15 plus 4 is negative 11/25. Square root both sides. Square root of 25 on the bottom is 5. Square root of negative 11, I can't do anything to. Make sure the plus or minus is there. And finally, I want to move the 2/5 over there. And I see a negative radical, that creates an imaginary number. So I'm going to extract an I from the radical and keep them separated like so. So that's the answer. Again, that's using completing the square technique. That will be usable every single time you get a problem like that. Solve a quadratic equation. Completing the square works. Technique 2. Get everything equal to 0 to use a quadratic formula. You have to have this form to use a quadratic formula. A is equal to the number in front of x squared. B is equal to the number in front of x, and C is equal to the number that's the constant. Signs included, so A is positive, B is negative, C is positive. I know that x equals that structure. What I need to do is figure out what goes here, here, and here. What goes here is minus B, which is positive 4. What goes on the bottom is 2 times A. 5 times 2 is 10. And what goes in there is B squared minus 4AC. B squared is 16. Whether or not B is positive or negative, when you square it, you get a positive. Minus 4 times 5 times 3. That's 16 minus 60, which is equal to negative 44. So altogether, I get 4 plus or minus the square root of negative 44 over 10. That's the same answer as that. A couple things need to be fixed. First of all, square root of negative 44. If I make that a plus and put an I out here, that's the first thing. 44 is 2 times 2 times 11, so a pair of 2's. So we're going to get plus or minus 2I times the square root of 11 all over 10. 4, 2, and 10 are all even, so you divide everything by 2. And again, I'm going to split because I got an imaginary. So 4/10 reduces to 2/5. And 2/10 reduces to 1/5, so 1 plus or minus the square root of 11/5 I. So there you are. I would expect you to get down to this level no matter what technique you use. Completing the square tends to get you to the simplest form, where sometimes quadratic form you have to modify it a little bit. But I mean, the modification is not very difficult math. So take your pick, but I do expect you to get me down to that level for each problem. 15, find the equation of the line that passes through the points. Nothing crazy about this. It's nothing perpendicular. It's just a basic Algebra 1 level. Find the equation of the line. X1, Y1, X2, Y2. The slope is Y2 minus Y1 over X2 minus X1. So 7 minus 4 over negative 4 minus 3. 7 minus 4 is positive 3. Negative 4 minus 3 is negative 7. So the slope is negative 3/7. And then y equals mx plus b. I'm going to use the slope, which we just found here, along with one of the 2 points. Doesn't matter which one. I like that 3, 4 better than negative 4, 7, since there's no negatives. So y, which is 4, equals m, negative 3/7, times x, positive 3, plus b. 3 times negative 3/7 is negative 9/7. Since that's a fraction, getting a common denominator here makes sense. 4 is the same as 28/7. Move the 9/7 over, and we get 37/7 equals b. So we have b, we have m, we have a structure, so we replace m and b with the numbers we just found. So the correct answer, y equals negative 3/7 x plus 37/7.